This is Precalculus section 2.2 part 2 notes. Our last graph that we're going to make today is going to be a piecewise function. There are different ways that you can graph a piecewise function. When I teach this in Algebra 2, I teach my students to graph both functions, draw the domain line, and then erase the part that they don't need. You could use the tables to graph the functions, or you can just know what the parent functions look like and you can sketch them, or you can use y equals mx plus b, whatever works for you for these problems. The first thing that I'm going to do is I'm going to graph kind of my domain line where I'm changing over from one function to the other, and that is taking place at the value x equals 2. So this vertical line right here is kind of the division point between where one function lives and where the other function lives. And again, I got that from this part right here on the equations. So x is greater than 2 tells me that the line x plus 3 just lives where x is greater than 2. So if I wanted to go ahead and make a table, I would just choose x values that are bigger than 2 and plug them in. So how about 3, 4, 5, and 6? And this is for f of x equals x plus 3. So now I'm just going to plug these in. 3 plus 3 is 6, 4 plus 3 is 7, 5 plus 3 is 8, 6 plus 3 is 9, and I can go ahead and I can plot these points. So 3, 6, 4, 7, 5, 8, 6, 9 would be up there. Okay. And I know that 2 is not included, so where it would intersect my line, it's going to have to be what we would call an open circle on that vertical line. My second graph is the function y equals x squared, but again, only for values of x that live less than or equal to 2. So how about for that table if I do positive 2, positive 1, 0, negative 1, and negative 2. I'm just going to do my fave 5. I'll throw an extra one on there. So this is for f of x equals x squared. So 2 squared is 4, 1 squared is 1, 0 squared is 0, negative 1 squared is 1, and negative 2 squared is positive 4. So when I graph these points, 0, 0, 1, 1, and negative 1, 1, and 2, 4, right there, and negative 2, 4. And of course the graph does continue on the left-hand side, but it stops on that green line on the right-hand side. So my piecewise function looks something like that. Final example today is a domain and range from a graph. So we have this picture, and you have the same picture in your notes, and we're just asked to use the graph to determine the following. So example number 1 asks, what is f of negative 2? So all they're asking is, when the value of x is negative 2, what is the value of the graph? So you look on the graph where x is negative 2, okay? So right here is x equals negative 2. Well, the value of the graph when x is negative 2 is y equals positive 2. For f of 3, if I go and find where x is 3, that's right here. So where does that fall on the graph? It looks like it's at about 3.25. You don't have to be super picky here. And then the domain of f of x is, where does this graph live along the x-axis? So again, we need to kind of look at the big picture here. Along the x-axis, my graph is living between here and here. So if we are going to write that as an inequality, that's going to be, let's see, x is in the middle, and it looks like there's, a closed circle on that point. And that is the value, x is negative 2. So we would say x such that negative 2 is less than or equal to x, which is less than or equal to, and over here my blue line is at positive 5. Sorry for the smooshing there between the negative 2 and the x. So that would be my domain of f of x. My range is going to be where this graph lives along the y-axis. So if I look at that next, where it lives along the y-axis is going to be down at negative 2 up to 1, 2, 3, up to positive 4. So I would say my range is my y value such that negative 2 is less than or equal to y, which is less than or equal to positive 4. again, just looking at that kind of rectangle or that picture frame where our graph is living in order to figure out our domain and our range.